about objective number 3, classifying real numbers. Now what real numbers are, all the numbers that you probably ever know are real, just like we talked about yesterday, all the numbers you knew are rational. Later in the year we'll talk about some numbers that are called imaginary, or complex numbers. That's kind of what Algebra 2 is about, some weird, crazy, funky stuff. But we'll start here with the real numbers. Now, this is like the family tree of real numbers. And it starts out by going, every real number goes into one of these two big categories, and that is rational, over here on the left, and irrational. And then underneath the rational, we'll break down and classify some of those rational numbers even further and further and further. Let's start with irrational numbers. We talked about that on a previous note. Irrational numbers, they're numbers that have decimals that go on forever but don't have any kind of pattern to them. So the numbers, I'll use the numbers on here, shorten this up. Numbers with never-ending and never patterning, repeating, and never repeating pattern. I don't know. We'll make up a word. Patterning. Decimals. So if you had one that a pattern could be just one number, like 3333, or it could be like 2 or 3 numbers. So you could say like 5.718, 718, 718, 718. That's pattern, right? Sometimes you don't see the decimals. A couple things you need to know is a couple of the big ones. Is pi is irrational? Don't be fooled though, like if somebody says 3.14, like that's fake pi, but like the pi symbol is 3.14159 and it goes on and on. Irrational. And then the other one is going to be weird square roots. Square roots that aren't that don't turn into just nice whole numbers. Like the square root of 25 is okay, but square root of 26 is bad. Square root of 27 is bad. Square root of 35 is bad. And then square root of 36 is good. So I'll just say weird square roots. Like square root of 37 or square root of 91, right? Those are weird square roots. Circle that. Pi is always irrational. Weird square roots are irrational. Just like second square root 83, right? I know it's weird because when I put it in my calculator like this, I hit enter and it says square root of 83. Even if I put in like square root of 50, it'll actually say something different, but if it gives you a square root back out, it is weird. It just, there's a way to reduce these square roots. And always if you toggle it, it's because it's 7.07106, 7, 8, 1, 2, no pattern, and just on and on and on. So that's the thing. Irrational numbers, the decimal never ends, it never makes a pattern. Pi is one of the most famous ones, and they come from weird square roots. Even if you see the square root of 37 like in a fraction or something, remember that it could have been like 3 over the square root of 37. Yeah, just if a square root is a part of it, a weird square root is a part of it, the whole thing's irrational. All right, that's it for irrational. Let's talk about rational. Now, rational numbers could have decimals or they might not have decimals. So let's go through. They could could be numbers with no decimals. They could be. They could be numbers with decimal patterns. It's one thing they could be. Or the third thing is they could be numbers with an ending decimal, like 2.75, right? An ending decimal. Might be more official to say like a finite number of decimals or something. So that's what rational numbers are. One, if they don't have a decimal at all, well, it can't be irrational. Irrational is all about chaos decimals. So if it doesn't have decimal at all, it's rational. If it does have a decimal pattern, 37, 37, 37, 37, it's also rational. Or if it just ends, like 2.78, rational. Now let's go down the family. Like, take all these numbers and then let's just focus on the ones that have no decimal. If you have no decimal, you're rational, but you even get a better name. So you have a name that's called integer. Here's the thing. Integers, these are the numbers that have no decimal. They're always rational. They are numbers with no decimal. And they could be positive or negative. Now, rational numbers, like all these things, can be positive or negative. But integers, you need to know, integers can be -5 or +5 or -7 or +12. Could be positive or negative. Could be positive or negative, okay? Okay, so that's all the integers. -50, -49, -48, -7, -6, -5, -4, -3, -2, -1, even 0, and then 1, 2, 3, 4, 5. These are all the integers. 1.7 ain't an integer, right? It's not. All right, now let's take all those integers, right? All negative infinity all the way up to positive infinity, integers. And if we just like threw out all the negative ones, well, then that's what we call whole numbers. So if we just threw them out, let's say whole numbers. I don't know why I stopped writing with capital letters here. Kind of messed that up. All right, here we go. Whole numbers. Now, what are whole numbers? We'll just write out what they are, starting with 0 is a whole number, and then up. 0 is a whole number. 1 is a whole number. 2 is a whole number. 3 is a whole number. 4, and then I'm going to put dot, dot, dot. The dot, dot, dot means I would keep going, 5, 6, 7, 8, but my pen will run out of ink, and I will be dead by the time I get to the end of all the whole numbers, because it just doesn't stop. All right, that's the whole numbers. Now there's one other part of this family tree right here, and it's say, let's take all those whole numbers, and let's just remove one of them, and then that's the next set, and that's called the natural numbers. Back to writing in all capitals there. Now, natural numbers means, all right, take them all. Just what we're gonna do is throw out 0, right? And then the natural numbers start at 1, 2, 3, 4. I don't know who came up with these and why we have the whole numbers and rational numbers. These are called sets. So the set of natural numbers is 1, 2, 3, 4, 5, 6. The set of whole numbers is the same thing, but it's got 0 in it. The set of integers is all the numbers, 0 and up or 0 and down, but they don't have decimals. Then you got rational numbers, and then you got real numbers, right? Your job is going to be, I'm going to give you a number, and you're going to have to tell me all the parts of the family it would go with. So if I said 2.6, well, okay, so 2.6, you'd have to go, okay, which side does it go on? Well, it's a decimal that stops, so it goes here. It's rational. And then you have to go, wait, 2.6, would it fall into this part of the family? No, because you can't have integers right there. I mean, can't have decimals right there. If I said something like -7, you go, okay, -7, real or rational? Oh, it doesn't have decimals at all, so it's rational. -7, is it an integer? Yeah, it doesn't have decimals, and it can be positive or negative. It's integer. Now, is it a whole number? No, because -7 would not be 0, 1, 2, 3, 4, 5. So it would just be real and rational and integer. So that's going to be kind of our job on this, is I'm going to give a number, you classify which parts of the family to go with, and you got to say all the parts. And a side note before we turn the page is, what are digits? Digits are digits are the buttons on your calculator or your phone, starting with 0, 0, 1, 2, 3, 4, 5, 7, 8, 9, and then that's it. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the symbols that we agreed upon a long time ago that'll make up all our numbers. So like 17 is not a digit. 17 is a 2-digit number. So keep that in mind. There'll be like a true-false question. Is 17 a digit? No, 17 is definitely not a digit. All right, let's fly through these examples really quick. Example 1 says, what's the best classification for the square root of 5? Anytime I see a square root, I'm going to ask myself, is that a normal square root or a weird one? Square root of 4 is normal because 2 times 2 is 4. Square root of 9 is normal because 3 times 3 is 9. But is there any number, like an integer number, that you can multiply by itself to get 5? No. Weird. It's weird. Remember, put square root of 5 in your calculator if you're not sure. Square root of 5. When you hit enter, it's going to say square root of 5. Because if you toggle that business, look, it's chaos. 2.236067978 and on and on and on and on and on. It is totally irrational. So what we're looking to say is, yeah, this number is irrational. And of course, you're also going to say it's real. It is real. It's just very irrational. Any weird square root is irrational and real. All right, next is, hey, I did this one the last time, just talking. What's negative 7? So 1, we know it's real. Negative 7 is definitely real. Okay, they all say real. Is it rational or irrational? Well, if it doesn't have any decimals at all, you definitely don't have to worry about it being irrational. So A is garbage. Okay, so negative 7, it's real. It is also rational, but then you have to say, would it be something else on that family tree? Negative 7, is it real? Yes. Is it rational? It has no decimals, so yes. Is it an integer? Well, it has no decimals, so yes. It can be positive or negative. It's an integer. Then would it be a whole number? No. But you do need to say it is real, and it is rational, and it would be an integer as well. So let's find that one. This is an okay answer, but this is the better answer. It is real. It is rational. It is an integer. But it is definitely not a whole an integer, and they didn't even include rational in there. All right, which of the following is true? So you got to go through these and say true and false. Let's see if we can remember. The set of whole numbers, this should be just written down on the back side of this paper. 0, 1, 2, 3, yeah, that's right. That is right. So that is true. And that was all we had to do, right? The set of whole numbers is 1. No, that's the natural numbers. These are confusing, though, so I want to make sure you know, why is this false? All real numbers are irrational. I don't know. All real numbers are rational. Remember our tree. Are all real numbers rational? No, we categorize like half of them here and half of them there. It might not be half and half, but some of them are real, or some of them are rational, and some of them are irrational. So not all real numbers are going on this side of the family. All right, what's the best classification for 0.2? Well, it's got a decimal, so obviously it's real. Everything's real. Every answer set's real. But is it rational or irrational? A decimal like that, 0.2? Was there any reason why that would be irrational? No. Irrationals have decimals that never stop, so that one's out. Okay, it is definitely rational. Now the next question you say is, okay, 0.2, it is rational. Would you call it an integer? Well, integers can't have decimals, so no. You see, would you call it a whole number or an integer? No, no. It is just real and rational. Remember, integers are things that have no decimals. Which is false. All right, so when you have these problems, I need your mind to go, look, I've got 4 statements. 3 of these statements are true. I've got to find the false one. All right, the set of odd integers. Negative 3, negative 2, 1, 0, 1, 2, 3. Wait, the set of odd integers, are you seeing a problem here? They said the set of odd integers, and they have numbers like this one and this one in there. So that's totally bogus. That's bad. This can't be odd integers if it's got a couple of evens in there. So if you're trying to find something false, it's right here. Now let's just check so you know why these are true. Now the set of integers is, see that it goes dot, dot, dot? That means it's going like forever negative. So it's just like going negative, negative, negative. Okay, let's say negative 3, negative 2, negative 1, 0, 1, 2, 3, and on and on and on. Those are the integers. Going negative this way, positive this way, not mentioning all of them, just using the dots instead. So that one is true. No problem. 0 is a non-positive integer. This one messes with some people. 0 is an integer. I told you that. Is 0 a negative integer? Nope. Is 0 a positive integer? Nope. So 0 is a non-positive integer. 0 is a not positive integer. It's an integer. It's just not positive or not negative. That is true. Okay. And now the set of integers is, let's see. What did that one say? The set of integers is, oh, the set of odd integers is, right? Check this. Odd integers. Negative 3. Yep. Negative 1. Yep. 1. Yep. 3, yep. So you notice they took the 2's and the 0's out. Yeah, those are the odd integers. Take out all the 2's and the 4's and the 0's on both sides of the 0. All right, so that one's true as well. All right, last one. Which of the following is false? So I've got true statements here all over, and one of them is false. Every integer is rational. Okay, that comes back to this tree. Every integer. See, like every integer, if you're part of this family, aren't you always part of this family and part of this family? Yes, so is every integer rational? Is every integer a whole number? No. Negative 7 is an integer. It's not a whole number, right? But negative 7 is an integer, and it's also rational because no decimals, and then it's also real. So is every integer a rational number? Heck yeah, it is. I already see the right answer. I already mentioned it before. Here you go. Now the set of even integers is, let's just check, negative 4, negative 2, 0, 2, 4. Right? Notice, did they take out the odds? Yeah. Are these integers? Oh, heck yeah, they are. Are they odd integers? No, these are the evens. These are the evens. They took out the 1s, the 3s, the 5s. So that's also true. Here we go. Here's Mr. False. The number 17 is a digit. Now, I mentioned that on the last page. I use that same number. Is 17 a digit? No, 17 is what we call a two-digit number. It's got a 1 and a 7. You, sir, are false, which means you are true. Now, this is one I want to point out. Last part of the notes here. I want to point out why the heck is this true, because you need to know on your problems, when you see it, this is true. A rational number can be expressed as the quotient. Quotient means dividing or fraction, right? Okay, a rational number can be expressed as the quotient a over b, where b not equal 0. Basically, it says, like in layman's terms, this says, hey, rational numbers can be written as fractions, a over b, like 7 over 9 or negative 5 over 2, as long as b is not 0. You can't have zeros on bottoms of fractions. So one thing, all rational numbers can be expressed as a fraction as long as the bottom isn't 0. That's a total true statement, and that is the end of the notes right there. All right, that wraps up objective number 3.